Good morning, students. Now, in this lecture, we are going to talk about a context switch topic, and then we'll talk about scheduling algorithms, their objectives, and the criteria to select a best scheduling algorithm. First, we start with context switch. A context switch, say, we mean that when there is a degree of multi-programming or multitasking in a system, how the process switches over from process 1 to process 2, and what happens to process 1 when process 2 takes its place over the CPU. Okay, so that process of moving from process 1 to process 2 is known as context switch. A context switch is the mechanism to store and restore the state of the context of a CPU in process control block, so that a process execution can be resumed from the same point at a later time. It is something similar कि if we leave a topic in between in a present lecture and we carry over that same topic in the next lecture on the next day, so that is known as context switching. Whichever topic we leave our discussion, we leave a class for a day, we take over the next lecture for a next day from the same very topic. So that is known as context switching. In simple terms, it is like loading and unloading of the process from running state to the ready state. Using this technique, a context switcher enables multiple processes to share a single CPU. It is something like for a day, you are being taught 5 subjects by 5 different teachers or 4 different teachers teaching you 5 different subjects for a day. So in a day, when your periods are switching from subject 1 to subject 2 to subject 3, this is the same process which is known as context switching. Context switching is an essential part of multitasking operating system. Obviously, an operating system where multiple tasks will be executing at a single moment of time. This is a diagram. For example, there is a process 1 which is executing. For a moment, process 1 preems and the process 2 comes into execution. So process 2 restores its state from the previous state where it left over. And once the process 2 is executing, after amount of execution for certain amount of time, the current state of process 2 is saved for later use, and process 1 is being allocated the CPU time. Process 1 starts from the same state where it has left previously. So P1 state जो सेव हुई थी वहीं से शुरू होगा next process 1 का execution. So this is a clear diagram which explains you what is context switching. Okay, when does context switching happens? जब high priority process comes to a ready state. We have discussed many number of times कि when process 1 is scheduling and there is some high priority process coming to a ready queue, then for the moment the execution time of process 1 will be aborted temporarily, and process 2, which is a high priority process than process 1, will be allotted the CPU time. So that is context switching. One reason, or an interrupt occurs, या user in kernel mode switches happens, या preemptive CPU scheduling is being used. There are CPU scheduling algorithms are categorized under 2 broad categories, preemptive scheduling and non-preemptive scheduling, already discussed in a previous lectures. Now that's all for context switching. Now we are moving on to the next topic, as you can see on your screens, CPU scheduling. Now there are various kinds of CPU scheduling algorithms. Before I start with each one of them, let's talk about what do you mean by scheduling and why do we need CPU scheduling at all. We say that scheduling of a process of work is done to finish the work on time. ओके हम लोग टाइम टेबल क्यों बनाते हैं अपने सेमेस्टर्स का, सो दैट कि हम समय रहते एग्ज़ाम से पहले अपना कोर्स का सिलेबस कंप्लीट कर सकें. सो दैट इज़ अ रीज़न वाई वी ड्रॉ अ शेड्यूल. वाई डू वी नीड शेड्यूलिंग? अ टिपिकल प्रोसेस इन्वॉल्व्स बोथ इनपुट आउटपुट टाइम एज वेल एज CPU टाइम. कोई भी प्रोसेस ऐसा नहीं होगा जो सिर्फ CPU टाइम रिक्वायर करेगा. उसको समय समय पे यूज़र से इनपुट भी चाहिए होगा और यूज़र को आउटपुट भी देना होगा. Based on the output from the program, the user is going to key in the input for the program, and based on the input given by the user, the program is going to, your process is going to execute. So any process involves 2 things. One is the CPU time and the other one is the input output time. So in a uni-programming systems like MS-DOS, time spent waiting for input-output is wasted and the CPU is free during this time. अगर हम यूनी प्रोग्रामिंग या यूनी सिंगल टास्किंग सिस्टम्स की बात करें तो MS-DOS उसका सबसे क्लासिक एग्जाम्पल है, जहाँ पर अगर कोई सिस्टम इनपुट आउटपुट के लिए वेट कर रहा है, डिवाइस क्यू में लगा हुआ है, तो फॉर दैट टाइम द CPU इज़ आइडल एंड CPU को कोई दूसरा प्रोसेस अलॉट नहीं होगा. So that time of CPU is being wasted out there. In multi-programming systems, one process can use CPU while other is waiting for input output. तो here the CPU का effective and efficient use होता है. So कभी भी CPU idle नहीं छूटता in case of multi-programming systems. This is possible only with the process scheduling. ये तभी possible है जब हम process scheduling algorithms use करें. Now what are the objectives of a process scheduling algorithm? Maximum CPU utilization so that CPU is kept busy as much as possible, fair allocation of CPU, maximum throughput. Throughput से मतलब है number of processes that complete their execution per unit of time. कि एक per unit of time में अगर हम 2 process execute कर पा रहे हैं और 5 process execute कर पा रहे हैं, तो second scenario में हमें maximum throughput मिल रहा है when compared to the first scenario. Minimum turnaround time, that is time taken by a process to finish its execution, should be as minimum as possible. Waiting time should be as minimum as possible. Waiting time is the time spent by a process in the ready queue. And response time, time when a process produces its first response is the response time. It should be minimum. So overall we can categorize that scheduling criteria under 2 categories, maximization and minimization. क्या मैक्सिमाइज करना है CPU यूटिलाइजेशन और थ्रूपुट को, क्या मिनिमाइज करना है टर्न अराउंड टाइम, वेटिंग टाइम एंड रिस्पॉन्स टाइम, जिसको हमने शॉर्ट में अभी देखा, उसी का इलेबोरेशन है ये. वी हैव टू मैक्सिमाइज एज वी सेड CPU यूटिलाइजेशन if the main task in which the operating system needs to make sure CPU remains as busy as possible. Okay, and number of processes that finish their execution per unit time is known as throughput. So जितना busy CPU होगा उतना बड़ा ज़्यादा उसका throughput होगा सिस्टम का. मिनिमाइज क्या करना है, वेटिंग टाइम को. द अमाउंट ऑफ टाइम स्पेंड इन द रेडी क्यू वो कम से कम होना चाहिए. रिस्पॉन्स टाइम इज एन अमाउंट ऑफ टाइम in which the request was submitted until the first response is produced. It should be as minimum as possible. आप लोग जब क्वेरी करते हो टीचर से तो आपका एक्सपेक्टेशन क्या होता है, कम से कम वक्त में टीचर आपको रिप्लाई करे. सो दैट इज़ अ रिस्पॉन्स टाइम. और जो टीचर जितना जल्दी रिस्पॉन्स देता है वो उसकी क्वालिटी उतनी अच्छी मानी जाती है. राइट. Turnaround time. Turnaround time is the amount of time to execute a specific process until it is the calculation of total time spent waiting to get into the memory and waiting in the queue and executing on the CPU. The period between the time of process submission to the completion time is known as the turnaround time of the process. So ये उसका summarized version है of all the times that we have discussed. And next is the scheduling algorithms that we were talking. There are basically 6 popular scheduling algorithms that we are going to discuss one by one in our lectures. First come first serve algorithm, that is FCFS scheduling algorithm. Shortest job next, yeah, shortest job first algorithm. Then priority scheduling, shortest remaining time algorithm, time slicing या round robin scheduling algorithm, and multiple level queue scheduling algorithm. So these are all there in your syllabus. We will be discussing each algorithm, and for each algorithm we will be discussing a numerical also, because oftenly in your examination you get a numerical question to solve based on each algorithm. These algorithms, as I said, they can be broadly classified as preemptive or non-preemptive. Non-preemptive algorithms are designed so that once process enters the running state, it cannot be preempted until it completes. इसका example है FCFS algorithm. और preemptive algorithm में क्या होता है, based on priority, where scheduler may preempt a low priority running process any time when a high priority enters into a ready state. Non-preemptive algorithm के सबसे classic example है round robin algorithm या priority based algorithm. So I sum up my session for today for the moment, and we'll continue our lecture on the live session for each of these algorithms. Thank you.